The roar of Merlin engines and the distant thud of bombs were the soundtrack to a nation's defiance. Britain, battered but unbowed, faced an existential threat, and its engineers, often unsung heroes, toiled in workshops shrouded in blackout curtains, their minds alight with ingenuity. Amidst the chaos of war, a seemingly mundane problem, the slow, arduous repair of battle-damaged tanks, threatened to cripple the Allied war effort. Little did anyone suspect that the solution, born from a uniquely British blend of pragmatism and sheer bloody-mindedness, would lie in something as unassuming as a bolt, a simple fastener that would utterly transform the battlefield, leaving the formidable German panzers in its dust, not in combat, but in the race back to the fight. The year was 1942. The war raged across North Africa and the Eastern Front, and the grim reality of armored warfare was starkly evident. Tanks, the spearhead of any offensive, were also incredibly vulnerable, their complex machinery susceptible to everything from enemy fire to mechanical failure in the harsh desert conditions. For every Sherman tank lost in battle, another was often sidelined by a broken track, a damaged engine component, or a shattered suspension unit. The problem wasn't just the initial damage, it was the agonizingly slow process of getting these behemoths back into the fray. British workshops, often makeshift affairs under canvas or in hastily converted sheds, hummed with the desperate energy of mechanics wrestling with recalcitrant machinery. The sheer volume of repairs was overwhelming, and every hour a tank spent out of action was an hour it wasn't supporting the infantry or pushing back the enemy. The American-supplied Sherman tank, while robust and reliable in many respects, still presented its own set of maintenance challenges. Its modular design was a step forward, certainly, but the myriad of fasteners, often of differing sizes and thread types, meant that a mechanic might spend precious minutes or even hours simply locating the correct spanner or wrench for a particular bolt. This seemingly minor inefficiency compounded across hundreds of tanks and thousands of repairs, translating into a significant strategic disadvantage. Meanwhile, intelligence reports from captured German panzers painted a picture of engineering marvels, intricate and formidable, yet burdened by a philosophy of over-engineering. German tanks, while technologically advanced, were notoriously difficult to repair in the field. Their components were often bespoke, requiring specialized tools and highly trained technicians, and their internal layouts were a mechanic's nightmare, demanding extensive disassembly to reach even minor faults. A broken track on a Panzer could mean days of work, often requiring a return to a dedicated repair depot far from the front lines. This stark contrast between the two approaches to military engineering became a critical point of focus for a small, dedicated team of British engineers and logistics experts. Based at a nondescript facility near Aldershot, a group of civilian engineers, many of whom had cut their teeth in the burgeoning British motor industry, alongside seasoned Royal Electrical and Mechanical Engineers, REME officers, began to scrutinize the problem. Their mandate was clear: find a way to drastically reduce tank repair times. The Blitz spirit permeated their work. The same resilience that saw Londoners clear rubble and carry on fueled these men and women in their pursuit of practical solutions. There was no room for academic niceties or theoretical perfection. The need was for speed, simplicity, and robustness. They understood that the battlefield was no place for delicate instruments or esoteric knowledge. Mechanics under fire, often exhausted and working in poor light, needed solutions that were intuitive and forgiving. The initial brainstorming sessions were a cacophony of ideas, some brilliant, some utterly impractical. One engineer, a quiet man named Arthur Finch, who had spent his pre-war years designing agricultural machinery, kept returning to a fundamental observation: the sheer diversity of fasteners. "It's the bolts, gentlemen," he'd often muse, his voice a low rumble. "Too many types, too many sizes. Every component seems to have its own peculiar fastening. It's a mechanic's purgatory." His colleagues, initially skeptical, began to see the wisdom in his seemingly simplistic diagnosis. They started to catalogue every single bolt, nut, and washer used in a Sherman tank, a painstaking process that revealed an astonishing array of variations. Imperial and metric threads, fine and coarse pitches, hexagonal and square heads, slotted and Phillips screws. The sheer lack of standardization was a logistical nightmare. The challenge was not merely to replace these with a single type, which was an impossibility given the varying stresses and functions of different components. Rather, it was to devise a system of standardization, a limited set of universal fasteners that could be applied across the vast majority of the tank's non-structural, easily replaceable components. This would mean redesigning mounting points, retooling production lines, and most importantly, convincing the Americans, who manufactured the Shermans, to adopt a British modification. It was a monumental task, fraught with bureaucratic hurdles and the inherent conservatism of large-scale military production. Yet the urgency of the war effort, coupled with the undeniable logic of Finch's proposal, began to gain traction. The team envisioned a future where a mechanic, armed with just a handful of standard tools, could swiftly dismantle and reassemble critical tank components, a stark contrast to the current laborious process. The potential impact on operational readiness was staggering, a true force multiplier that could turn the tide of battle not through superior firepower, but through sheer, relentless availability. The question remained, could this audacious vision be translated into a tangible reality, and would it truly make a difference when the mud and blood of the battlefield called? The concept, once articulated by Finch and his team, quickly moved from theoretical discussion to the drawing board. The universal fastening system, as it was tentatively dubbed, wasn't about inventing a new type of bolt, but rather about rigorously standardizing existing robust designs. The team settled on a limited palette of high-tensile steel bolts, primarily using a unified thread standard, UNF, that offered a good balance of strength and ease of manufacture and, crucially, a consistent hexagonal head size for each diameter. This meant that a mechanic would no longer need to rummage through a dozen spanners. A single set of 3 or 4 common sizes would suffice for the vast majority of field repairs. The elegance lay in its simplicity, a hallmark of good British engineering, practical, durable, and utterly devoid of unnecessary complexity. The initial prototypes were manufactured in small, dedicated workshops, often under the constant threat of air raids. The rhythmic clang of hammers and the whine of lathes continued, even as air raid sirens wailed, a testament to the unwavering resolve of the British workforce. Women, many of whom had never worked in heavy industry before the war, became adept at operating machinery, their nimble fingers and keen eyes proving invaluable in the precise manufacturing of these new components. There was a palpable sense of shared purpose, a quiet determination to contribute to the war effort, no matter how small the individual task seemed. Churchill's defiant speeches echoed in their minds, reinforcing the belief that every rivet, every bolt, played a part in the larger struggle. The challenge of integrating this new system into the Sherman's production was formidable. It required close collaboration with American manufacturers, who, understandably, were initially hesitant to alter their established production lines for a British modification. However, the compelling data presented by the Aldershot team, projections of drastically reduced repair times and increased tank availability, eventually won them over. The sheer logistical nightmare of supplying a multitude of different fasteners to the front lines was also a powerful argument. A simplified inventory meant easier supply chains, less confusion, and ultimately more efficient operations. The first Shermans incorporating the British-designed universal bolt system began to roll off the production lines in late 1943, destined for the battlefields of Italy and, crucially, for the impending invasion of Northwest Europe. The true test, however, would come not in the sterile environment of a factory, but in the brutal crucible of combat. The first reports from the field were cautiously optimistic. Mechanics, initially wary of any newfangled system, quickly appreciated the tangible benefits. Sergeant Major Thomas "Tommy" Atkins, a grizzled Remy veteran serving with the 8th Army in Italy, recounted his initial experience with the modified Shermans. "Bloody marvelous it was," he'd grumble, a rare smile creasing his weathered face. "Before, you'd spend half the night trying to find the right spanner for a track link, fumbling in the dark with a torch. Now, one size fits most, practically. You could do it blindfolded, almost." This anecdotal evidence was soon backed by hard data. Repair depots began reporting significant reductions in the time taken to complete common repairs. A track replacement, which previously might have taken a skilled crew several hours, could now be accomplished in a fraction of that time. Engine access panels, once a puzzle of varying fasteners, now yielded quickly to a standard tool. The make-do-and-mend philosophy, so ingrained in British wartime culture, found its ultimate expression in this bolt system. It wasn't about replacing entire components with new ones. It was about making the repair process itself more efficient, enabling damaged tanks to be patched up and sent back into the fray with unprecedented speed. This meant fewer tanks languishing in rear areas, fewer resources tied up in complex logistics, and more fighting power at the front. The system was robust, designed to withstand the rigors of battlefield conditions, and simple enough that even less experienced mechanics could quickly become proficient. The initial skepticism gave way to widespread acceptance and even enthusiasm among the ground crews. They were the ones who truly understood the value of every minute saved. Every tank returned to action. The universal fastening system, born from a quiet observation in a British workshop, was proving its worth, not with a bang, but with the quiet efficiency of a well-oiled machine, ready to confront the operational realities of a global war. As the modified Shermans began to proliferate across the Allied fronts, particularly in the build-up to D-Day and the subsequent push through France, the impact of the British bolt system started to become apparent, not just to Allied mechanics, but inadvertently to the German forces they faced. German intelligence, meticulous in its analysis of enemy equipment, began to notice a perplexing trend. Allied tanks, particularly the Shermans, seemed to reappear on the battlefield with an unnerving rapidity after being damaged. A tank that had been knocked out in a morning skirmish might be seen again, patched up and ready for action by the afternoon or the following day. This was in stark contrast to their own experiences, where a damaged Panzer often meant a lengthy recovery and repair process, sometimes taking days or even weeks, requiring specialized equipment and highly trained personnel. Captured German mechanics and engineers, interrogated by Allied intelligence, expressed genuine bewilderment. They spoke of the intricate, often over-engineered designs of their own tanks, where every component, while robust, seemed to demand a unique approach to repair. The Panther and Tiger tanks, formidable in combat, were logistical nightmares when it came to maintenance. A simple track repair on a Tiger, for instance, could involve a complex sequence of operations, often requiring a crane to lift the heavy track sections and a full complement of specialized tools. The idea that an enemy tank could be repaired 4 times faster than their own seemed almost fantastical, a testament to some unknown, perhaps even unfair, Allied advantage. They couldn't fathom the simplicity of the British solution. Their engineering philosophy, rooted in precision and bespoke design, blinded them to the power of pragmatic standardization. The operational validation of the universal fastening system was undeniable. Detailed reports from REME workshops in Normandy and beyond painted a clear picture. Average repair times for common battlefield damage, track breaks, suspension damage, minor engine faults, and even turret ring issues plummeted. Where a Panzer might take 12–16 hours to return to operational status after a track hit, a Sherman with the new bolt system could be back in action in as little as 3 to 4 hours. This wasn't just a marginal improvement, It was a strategic game-changer. It meant that Allied armoured divisions maintained a higher operational readiness rate, could absorb more punishment, and sustain offensive momentum for longer periods. The sheer volume of tanks available for combat at any given moment increased dramatically, effectively multiplying their fighting strength without needing to produce more tanks. The psychological impact on the Allied troops was also significant. Tank crews knew that if their vehicle was damaged, there was a very good chance it would be repaired quickly and they would be back in the fight with their comrades. This fostered a sense of confidence and resilience, knowing that their equipment, while not invincible, was recoverable. For the mechanics, it was a source of immense pride. Working under often harrowing conditions, with enemy shelling a constant threat, they were the unsung heroes who kept the steel beasts rolling. The British dry wit often surfaced even in these grim circumstances. Remy Corporal, after swiftly replacing a damaged road wheel on a Sherman under fire, reportedly quipped, "Right, that's another one for Jerry to scratch his head over. Thought he'd put us out of business, did he? Not today, old chap, not today." The system's success was a quiet triumph of British ingenuity and pragmatism over the perceived superiority of German engineering. While the Germans focused on creating individual masterpieces of mechanical complexity, the British, with their make do and mend ethos, focused on the operational efficiency of the entire fighting force. It was a lesson in the strategic value of simplicity and standardization. The Bolt system, initially conceived as a minor logistical improvement, had evolved into a critical factor in maintaining Allied armoured superiority, allowing Shermans to absorb damage and return to the fray with a speed that utterly confounded their adversaries. It was a testament to the fact that victory in war often hinges not just on grand strategies or technological breakthroughs, but on the cumulative effect of countless small, practical innovations, each contributing to the relentless grind of combat. The war eventually drew to a close, but the quiet revolution wrought by the British-designed Bolt system continued to resonate far beyond the battlefields of Europe. Its impact on military logistics and engineering principles was profound and enduring. The concept of standardization, once a secondary consideration, was elevated to a paramount concern in the design and maintenance of military hardware. The lessons learned from the Sherman's rapid repair capabilities directly influenced post-war tank design, not just in Britain but across the Western Allies. Future generations of armoured vehicles, from the Centurion to the Chieftain, incorporated modular designs and universal fastening systems as a fundamental requirement, ensuring that field maintenance remained as efficient as possible. The era of bespoke, over-engineered components, particularly for easily replaceable parts, was largely over. The legacy of this innovation extended beyond tanks. The principles of simplified maintenance, common tooling, and interchangeable parts became cornerstones of military equipment design across all branches of the armed forces. From aircraft to artillery, the drive for operational readiness through ease of repair became a guiding philosophy. This shift was a direct consequence of the wartime experience, where the ability to quickly return assets to service proved as vital as their initial combat effectiveness. It was a testament to the foresight of Arthur Finch and his team, whose pragmatic approach had fundamentally transformed military engineering. Their work, often overshadowed by the more dramatic stories of combat and heroism, was a quiet yet utterly essential contribution to the Allied victory. The story of the Bolt system also serves as a powerful illustration of British values during the war. Ingenuity under pressure, a pragmatic approach to problem-solving, and the collective effort of a nation. It wasn't a single heroic act, but the culmination of countless hours of meticulous work by engineers, factory workers, and mechanics, all united by a common purpose. The Blitz spirit wasn't just about enduring bombing raids, it was about finding practical solutions to unprecedented challenges, often with limited resources. The make do and mend philosophy, born of necessity, became a powerful driver of innovation, demonstrating that sometimes the simplest solutions are the most effective. This understated brilliance, a hallmark of British character, proved to be a formidable weapon in its own right. Historians and military analysts in their post-war assessments often highlighted the strategic advantage gained by the Allies through superior logistics and maintenance. While German tanks were often technically superior in individual engagements, their inability to sustain operational readiness due to complex repair requirements ultimately hampered their overall effectiveness. The British Bolt system, by dramatically reducing the downtime of Sherman tanks, directly contributed to this Allied advantage, ensuring that numerical superiority could be maintained and exploited. It was a silent battle won in the workshops and repair depots, far from the front lines, but with profound implications for the outcome of the war. Today, the principles pioneered by that small team in Aldershot are taken for granted in modern military and even civilian engineering. The idea of standardized components, ease of maintenance and modular design is ubiquitous. Yet few remember the specific wartime innovation that helped cement these principles. It stands as a quiet monument to the unsung heroes of the Second World War. The engineers, the mechanics, the factory workers, whose dedication and ingenuity ensured that the fighting men had the tools and the machines they needed to prevail. Their legacy is not in a grand monument, but in the enduring efficiency and reliability of the equipment that continues to serve, a testament to how a seemingly minor detail, a simple bolt, could transform the course of history. Discover more untold stories of wartime ingenuity and the remarkable individuals who shaped history. Subscribe to our channel for exclusive content and join the conversation in the comments below. Your insights and questions help us bring these vital narratives to life.